In this video, I want to do a quick tech breakdown explaining how I implemented the audio systems in Unreal Engine and Wwise for this immersive ambience and character embodiment demo. So to start out, each ambience is going to be a trigger box. There's one for the house and the gazebo and so on. That's just a big volume that says where the ambience should be active. And each one of these is associated with doorways. So wherever there's a doorway, you'll place an actor, a BP doorway child actor that has a left and right scene component saying where the edges of that threshold are. Starting at the bottom with these doorways, we're going to look at that line segment created by the scene component and then find the closest point on that line segment to the character's location that's accepted as the input. Outputting then the distance to the doorway, the door's world location, and then the openness of that doorway, which we can set from 0 to 1 in case you wanted to add doors or other objects like the blinds where the door exists, but it can be closed off. Moving up, the ambience is where we're going to be scanning these doorways and looking for the distance. So on each ambience, we'll have associated by tag all the doorways that's part of it. So instead of the church scanning the gazebo's doorways, it's only going to be looking at the church tag doorways. And once we have that array of the relevant doorways, we'll loop through and call getMin distance to door on each door, filtering out eventually the best two doors. So we'll have the very closest door and then the second closest door, and we can run getMin distance to door on both of those again to kind of really specify the location, the distance, and the spatialization using the azimuth. So what this will do is we'll basically treat the camera's forward location as 0 degrees, and then measuring the azimuth from that angle of each one of these doorways is going to tell us where the doorway is located relative to the camera in space. Is it 90 degrees to the right, directly behind, or directly in front, and so on. So after getting the azimuth and all these distances, we're outputting all of this information as the return node of this function. And one thing that might require a little bit of explanation is this variable of indoorness. So all this cares about is what's the closest door and how does that compare to the fully indoors distance? Now, fully indoors distance is just set by me or whoever it is. You'll just look at the ambience and play around and say, well, how far into this church do I want to be in order to be considered fully indoors? So on this church, I've set it as 25, but if I set it as a higher number, I would need to go further and further away from the doorways to be considered fully indoors and not hear any wind, and also only hear the church ambience. So moving back to this function, this is really the core of how we're cycling through all of the doorways and querying them for information about their location. Moving up to the character, this is where we're taking that information returned by getIndoorness at location and using it to transfer to RTPCs in Wwise. Most of that's happening on the wind, but some of it's also happening when we update the reverb and the actual ambience that's playing. In the church, there's those low organs, and in the house, kind of a low buzz with wood creaking. We're going to update all of that information, as well as the really complicated part is just going to the wind so that we can hear the outside coming through the doors. The indoor ambience has no spatialization. When you're inside the church, there's spatialized objects like the bells, but the actual ambience itself is just playing not globally, but statically around the character. It's not moving around. Moving now to the wind actor, this is where we see that we're taking all of this information that was gathered from getIndoorness at location and setting these RTPCs values on the wind with some interpolation time to smooth it out. But this way, whenever let's say for instance, I am inside of a building and then I exit, immediately on the event tick, once I'm outside, I'll say, okay, there's 0 active ambience. That means I'm going to set that I'm not inside and use this function to set outside, which is basically going to look at all of these. Here, let's open it up. All of these variables and set them to a default value. There's no spatialization. The wind is just fully stereo and turned all the way up. And back here on the event graph, if instead there were active ambiences and I was inside, I'll loop through all the active ambiences, get indoorness at location, and set that as the wind pan instead of using these outdoor values to set the wind pan. So that's pretty much it, how it works to get that spatialized wind sound through the doors when you're inside these big open spaces. The other thing I wanted to go over briefly was the footsteps. So once we receive the footstep anim notify that's been put on the animations, we'll run this function get surface type to first check which foot is lower, get the location of ball L and ball R, and get the vertical component of that vector, compare them to say, okay, left foot's lower, we're going to use left side switch, and then line trace by channel from that particular socket, and get the surface that's below the lowest foot at any given time. So now that we've covered most of the blueprint logic, I want to jump into Wwise and show some of these game parameters and how they're driving the RTPCs over here. So in the Game Syncs tab, you can see all of these game parameters controlling RTPCs that are being shared over. And right now it's split up on the wind pan and wind volume. If I was to continue implementing with the system in the future, I think I'd probably try to put 2 AK components on the wind actor so that we could sort of separate left and right as separate objects and then control each one with its own RTPC instead of having 2 RTPCs here. But this is how it's set up right now. Moving into the wind, you can see that within this actor mixer here, there's 2 sides. One is going to be the left and 2 is going to be the right, and then when indoors, 1 will be the closest door and 2 will be the second closest door. Now, the panning is actually controlled even closer with the lower sort of rumbly wind component having a delicate panning, and the higher crispy wind component is panned more aggressively so that you get that spatialization, but you still feel that immensity and the feeling of the low frequencies kind of wrapping around your head, because at 40 hertz, the wavelength is 20 feet long. It could be it really has no spatialization if you get super low. So the footsteps here is really just set up in this nested switch container. There's a rustling layer of this kind of deep low mechanical whining, and there's this nested switch where first we switch on material and then switch to the foot side. Every time it comes through, it's just the same footstep notify with a lot of switch information saying exactly which container to pull from. And most of the rest of the audio that's set up here is just interactable objects like the speakers and the bells, which have spatialization enabled. They're just 3D emitters in the world, and then they also have an attenuation curve for that moment at the end with the occlusion on the sort of transparent pink wall. Just set up a low pass filter and some volume RTPCs there. And then the last one is the internal ambience transition. Now, this is the part where there are some limitations with this implementation because it's controlled as a RTPC. When moving through these ambiences, they have to happen in order, or you'll hear the RTPC cycle through a bunch of unrelated ambiences. For instance, if I walk into the church after the gazebo, I'll pass through the tunnel ambience if that was set up. And so you get this kind of unnatural cycling if you go out of order. But as long as one indoor ambience comes directly after the other, then it's totally smooth. And then always when going from an indoor ambience into outdoor, it will always be smooth and modulated by indoorness, so that the ambience as a whole, kind of as indoorness increases, you hear more of that internal ambience. So when you first enter from outside and it's cycling through those ambiences to get to the right one, then it'll be so low that you don't hear it. It will have gotten to the correct ambience by the time that the level's high enough. So it works and it's natural, but it does not create a good opportunity for having multiple different indoor ambiences with different paths that may put them out of order. But I feel like for a lot of applications, this will work naturally. Anyways, that's pretty much it.